Gabriel!
Hello everyone, Eric here. Today I'll be bringing you my 2018 Petrosains Science Show Competition video submission. And today we have a very special guest here. His name is Gabriel. He's the one from last year's submission video. And he is here today to join me to narrate throughout the video. So without further ado, let's get in with the show.
Salt. What is salt? When we say salt, we are actually referring to table salt, otherwise known as sodium chloride. But in the field of science, the simplified definition of salt refers to an ionic compound that can be formed through various means, like the neutralization of the combination of certain acids and bases, or even the double decomposition method between two different kinds of salt. Also, there are salts that can't be dissolved in water, known as insoluble salts. Now, we who represent SMJK Chong Hwa will bring you 4 different kinds of experiments to discover the enigmatic properties of salt.
Yeah. The Sub-Zero Ice Experiment. Did you know that salt can change the properties of water in interesting ways? Being an impurity when dissolved in water, it helps to bring the boiling point and melting point of water to a higher temperature. By taking advantage of this property, we can actually make ice that is colder than 0 degrees centigrade. For this experiment, we will need table salt, ice, a beaker, and lastly, a thermometer. Firstly, we put some ice into a beaker. Then, we will measure the initial temperature of the ice. As expected, the temperature of pure ice is 0 degrees centigrade. Next, we introduce salt into the ice and mix it in. Now, when we measure the temperature, we can obviously see that the temperature is below 0 degrees centigrade. The ice produced is very cold, so please avoid prolonged exposure of your body parts into the ice to prevent nasty frostbites. Also, it is highly recommended that you do not consume this mixture because the salt content is extremely high.
The conductive liquid experiment. Salt, when dissolved in water, also helps to increase the conductivity of the water. This is because it forms a solution with freely moving ions that are able to carry the electric current because of their ability to move freely in the solution. For this experiment, we will need table salt, a beaker, distilled water, carbon electrodes, alligator clip wires, a light bulb, an ammeter, batteries, and a battery holder. Firstly, we make a closed circuit that includes the light bulb, batteries, battery holder, and an ammeter. Then we break the circuit and attach carbon electrodes to each end of the wires. Next, we dip the carbon electrodes in a beaker containing distilled water. The needle on the ammeter shows no deflection, and the light bulb isn't lighted up at all. This proves that distilled water or deionized water cannot conduct electricity. Moving on, we will now dissolve table salt into the distilled water. After it is completely dissolved, we then dip the carbon electrodes into the table salt solution. We can observe that there is a deflection on the ammeter, and the light bulb also lights up. This proves that water containing salt will conduct electricity. This solution is called an electrolyte. For example, in our bodies, the muscle and neurons are activated by electrolyte activity between the interstitial fluid and intracellular fluid. The lack of electrolytes in our bodies will result in conditions such as muscle cramps. Handle the light bulb and glass apparatus carefully as broken shards of glass are very dangerous. The electric current produced is low enough so it's negligible and doesn't pose any health risk.
Whoa, crystallized already.
Yeah, one. Do you film it?
Yeah, it's filmed. Yay!
The hot ice experiment. Hot ice refers to a salt crystal structure formed with supersaturated sodium acetate solution when poured onto a rough surface. But the experiment that we are doing will have a significantly more beautiful result, as the crystal form actually follows the crystalline structure of the salt. Besides, the formation is very rapid. For this experiment, we will need sodium acetate trihydrate, distilled water, Bunsen burner, tripod stand, wire gauze, an electronic balance, a measuring cylinder, and a glass stirrer plus a paraffin. Firstly, heat up 160 grams of sodium acetate trihydrate with 30 ml of distilled water. Next, stir the solution slowly until all of the solid is dissolved. If there are any crystals forming at the sides of the flask, rinse them down with small squirts of distilled water. After that, cover the flask with paraffin and let the solution to cool down to room temperature undisturbed. Take care to not disturb the solution, as even the slight movement may cause the crystallization to occur before you're ready. Now when the solution has cooled down to room temperature, grab a small crystal and drop it into the cooled solution and watch as a beautiful needle-like crystal structure blooms from the small crystal. A supersaturated solution of sodium acetate trihydrate will recrystallize by the addition of a single crystal of the solid. A supersaturated solution is a solution which contains greater amount of dissolved substance than is present in a saturated solution at the same temperature. A supersaturated solution can be made by gradually cooling a saturated solution without agitation so that the crystals do not form. Supersaturated solutions are extremely unstable and will precipitate or crystallize upon addition of just one crystal of the solid. Even slight shaking or agitation may be enough to cause crystallization to begin. Sodium acetate is very slightly toxic by ingestion, inhalation, and skin absorption. So please wear gloves when in contact with the solution and avoid drinking this solution.
Especially this one.
Gabriel, after that, go! Done!
The rainbow flame experiment. Fireworks go by various different colors and have fascinated us so much that we use them to entertain ourselves during celebrations. The experiment that we will conduct will show the proof of concept behind how the fireworks exhibit their colorful nature. For this experiment, we will need methanol, table salt, lithium chloride and hydrous calcium chloride, copper 2 borate, copper 2 sulfate, potassium chlorate, crucible, lighter, and a wooden splinter. Firstly, we put each of the salts in their own separate crucible. Next, we add methanol to each of them, and then light them up using a burning wooden splinter. Now, we can observe that the table salt burns with a yellowish flame, the lithium chloride burns with a reddish flame, the calcium chloride burns with an orange-yellow flame, the copper 2 borate burns with a green flame, the copper 2 sulfate burns with a turquoise blue flame, and the potassium chloride burns with a pale magenta flame. This is because by burning the salts, its atoms receive energy. This allows its electrons to change into a higher energy state. So, when it drops down to a lower energy state because not all of the heat is transferred efficiently to it, it releases a photon of light. The photon produced will have an energy equal to the difference between the electron's initial high energy state and the later lower energy state. For visible light, we perceive this difference in photon energy as difference in the color of the light. Because different types of atoms have different gaps between their energy levels, they make light of different colors when their electrons lose energy. Not only can this be used to create fireworks shows, but astronomers can use this knowledge to figure out the atomic composition of distant stars. Do not breathe in the dust from the chemicals and wear gloves when handling them to prevent contact with skin. Also, avoid breathing too much combustion fumes produced during this experiment. Lastly, prepare a fire extinguisher just in case something goes wrong.
Thank you for watching this video till the very end. If you like this video, give it a thumbs up. If you dislike it, then dislike it. We'll see you next time if fate allows it.
Is it not for me?
Gabriel teaching how to use a tester.
I thought you always do house chores, one.
Sorry, we don't use this. We use blender.
Blender is not good.
Technology.